Okay, let's begin. Hello everyone. Here I would introduce the third place solution for Java AI 2003 Global Knowledge Tracing Challenge. And the name of my report is Effective Information Extraction of Time Series for Knowledge Tracing. This competition can be reduced as such a problem. The order which students do solve the problems is given uh, with the format of time series. Each question has its knowledge components, and one question can have several knowledge components. Now, some responses are masked, and we need to predict the levels of them. And the metric of this competition is AUC. Uh, we use a tree model to solve this problem with some manual features and a little embedding features, which makes full advantage of the gradient tree model. Besides, some ensemble methods are also used in our solution, such as different sets of features and different sets of parameters. And we also use methods like data augmentation and the weight method to reach a higher score. In fact, it has also been found that there is still a large space for improvement by a larger data set. So the whole data set was used to train and receive the best single GBM model with a score of 0.8153 on public leaderboard, and after ensemble, it can reach a score of 0.816. Furthermore, since the lack of time, we only use that GBM model. Other models like XGBA, and or Tabnet using manual features may also lead to improvement, but uh, we don't have enough time to make a try. We also found that these, these manual features can also improve deep models like transformer by concatenating, but uh, it's a pity we also don't have enough time to make a chart. Here, I would introduce the whole structure of my solution. First, some data cleaning is checked, such like students with better accuracy almost have no possibility to get a question right unless it is a choice question. But the data cleaning model only works a little. In the feature engineering model, I have just features of users, questions, and the features between different users and the questions. Besides, uh, auto-factor embedding with question sequences can also improve a lot of score. In the feature selection model, all these three methods have been tried. Uh, we need to uh, reduce the gap between chain validation and the test sets. And after recursive features elimination, scores could be improved. After that, data augment k-folds experiments and the training weight experiments also lead to an improvement. Finally, two best sets of parameters and three best sets of features were chosen respectively. Those six models in ensemble gives another improvement. We tried the step flow embedding methods such as word to factor, node to factor, random walk, and TF-IDF, and so on. The result is word to factor model without fine-tune can give a little improvement, and after fine-tune, it could give another 0.001 points on the public leaderboard. My two-factor models uses time sequence of questions which comes from students' problem paths. Lost items CF like features. Lost items CF-like features is very important for our models. You can see here. Suppose that question 3 and question 4 are similar. So after one student finished his question 3, and the accuracy of his question 4 would be promoted largely. So this kind of promotion could be called as item safe. And after this matrix done, we can extract more features like using group by and using different time window like 2 hours, 1 day, 7 days, and so on. But only using the 0.1 is insufficient. So some bad cases would sometimes happen and it would largely break the features you make. So a limitation of so we must limit the similarity of knowledge components. Here we can use knowledge components of question 3, XOR components of question 4, and when its length is smaller than 1, we can suppose these two questions are more likely to be similar. Sorry. In the feature selection model, these three methods are used. First, we need to guarantee the gap between train and validation sets is small on error feature. We can choose one feature, train a simple model, and measure whether the score on train set is much larger than validation set. Next, we need also guarantee the gap between train and test sets is small on every feature. We can choose one feature and suppose the level of train set is 1 and while the level of test set is 0. We can use this feature f and the fake label to train a model. And when AOC is much larger than 0.5, this feature f may have a leakage, or it is a bad feature and we will not use this feature. Uh, Finally, recursive feature elimination is used to get a better feature set in greedy. For example, uh, if we delete this feature and the score the score the AOC score improves, so we will delete it. Here for data augmentation, we could randomly mask labels of the chain set, which could lead to a better score. Besides, K-fold by UID sequence length could reduce the gap between each K-fold splits, and use UID accuracy as the weight of chain samples can reduce gap between chain set and test set. Finally is a model ensemble. Two sets of parameters and are given by the tool Optuna, and the three sets of features were chosen by the feature selection methods mentioned before. In this way, we can get 6 models, and we ensemble and the models ensemble gives another improvement from uh, from 0.8153 to 0.816 in public leaderboard. So this is all my report for our solution. Thank you.